All right, so now we're going to take a look at exponential functions. An exponential function has the form f of x equals, we'll use a times b to the exponent x, where a is the initial or starting amount, and a cannot equal 0. If it does, then the whole equation equals 0. B is the growth or decay factor per unit of x, and b has to be greater than 0 and it cannot equal 1. So there's a couple of things about b. If b is larger than 1, okay, think of that 1 as a percentage. So if it's larger than 1, then it's larger than 100%. So the exponential function is growing or increasing. If that factor is between 0 and 1, in other words, a fraction like 1/2 or 2/3 or 0.7, then it's decaying or decreasing. So here's one thing to remember. An exponential function grows or decays by a rate proportional to the amount present. In example 1, it states the population growth of a small country is described by the function p of t equals 28 times 1.065 to the power of t, where t is in years, and p, the population, is in millions. So even before we answer these questions, let's take a look at that equation. So 28 is our A, so that is our starting amount. That means the population at the beginning of whatever study we're doing would have been 28 million. This number here is our B. Since it's larger than 1, that means we have a growth factor. So you can think of it as the 1 representing 100%, in other words, the entire original population. And then that extra 0.065 means it's increased an extra 6.5%. So you have 100% of the original plus an extra 6.5% of the original. That's what we meant by it being in proportion to the amount that's already existed. That's why it's being multiplied by 28. So that's the rate at which it's growing every year. So let's answer part A. Is determine P, again, that's the population, when T is 0. So P of 0 equals 28 times 1.065 to the 0. Remember, anything to the 0 power is 1. So this to the 0 power is 1. That leaves us with 28. Well, we already kind of talked about our A being our starting amount. So what does this quantity represent? This means at the start, our initial population was 28 million people. Then it asks us to determine P, the population, when T is 10. So our time is 10 years. And what does that quantity represent? Well, P of 10 equals 28 times 1.065 to the 10, and that is approximately 52.56. Remember to put all of that in your calculator at once. And so what does that mean? Well, if T is 10, that just means 10 years later from our start, the population is 52.56 million people. As a side note, sometimes they will say T represents years after, let's say, 1970. Then that means T equals 0 would represent 1970. And if T equals 10, that would represent 1980. So sometimes they just say T is in years and it's generic, but sometimes they'll actually give you a date. So, and it's just easier to work with zeros and tens than 1970 or 2012. So just make yourself a little note in the problem so when you interpret it, you're interpreting it with the correct dates.